Hello everyone, welcome back to my channel. In this video I will show you how to compile Quantum Espresso using Intel Parallel Studio. But before we start the compilation process, I would like to show you two important resources that may help the compilation process. The one is the documentation in Quantum Espresso official website. Another one is the link advisor of Intel Math Library in Intel's official website. The way that you can find it is quite simple. Just Google not configure but compilation Quantum Espresso, and the first one would be the official documentation that I show here. And if you type in Intel MKL link advisor, the first one is what we need. Let's first take a look here. So it basically tells you what to do in the compilation process. The command that we will use is something like this. And in the math library of Intel, so you have to choose which version do you use. We use MKL 2019, or we choose this Parallel Studio 2018. Doesn't matter. So we use Linux, yes, and Fortran. This is 64-bit, dynamic usually, and 32 integer, and we use sequential. In principle, you could also use OpenMP and TBB threading, but since we use Intel MPI, we use the MPI standard. We don't really need those two things. But in the end, you could try to set it to OpenMP threading or TBB threading to see whether it can increase the performance. To my knowledge, it does not really increase the performance, so I will select sequential here. And select this scalar pack and plus, and we use MPI library, that's Intel MPI, and link it explicitly, and we will get this line. This line is what we need to put into make.in inc file. Okay, so let's first start with the command line. Ctrl-Alt-T, and we first check whether ifort is installed. ICC. Remember last time that we have to source properly. So we have to source. So basically that is add the environment variable to the current terminal. Source. What we have is Intel and Parallel Studio and bin. I don't remember. It's ps.sh. Okay. So now if we check again, ifort -v, we see everything is in the environment. Okay. So everything is set. We go into the folder and we go into the folder that I prepare for the new compilation. And what we want to do is configure. But this time we want to pass what compiler we want to use into the command, which is basically here. We want to specify MPI F90 equals MPI ifort. So we want to specify that the parallel version of the Fortran compiler is MPI ifort. This is the version in Intel compiler, and CC equals MPI ICC. This is the C compiler. F90, that is the Fortran compiler, and F77, that is the just use MPI port. Okay, and then I think yeah, we can specify enable parallel, but this is not necessary because this is by default enabled, and we just enter. Yeah. Okay, you see that parallel environment detected successfully. That's good, and it also detects the blast leaps within the Intel MKL. Yeah. So, but this is not enough. If you just run this code, it may still give you some error, or may not. But one another thing you can see here is that FFT leaps. So there's no specification for the FFT leaps. So probably it will still use the internal version that is not very efficient. And then what you want to do is to go into the folder and modify the make.inc file. Yeah. How do you modify the make.inc file? We just scroll down and see that here it is MPI ifort, MPI ICC, MPI ifort. So this is correct. CPP, we don't have to change the preprocessor. And here we notice that this is F flags are -02. This is not very efficient because 03 is the highest level of optimization. Yeah. This 00 we don't change because this is the specifically for Fortran 77. And it does not it is not compatible with high level optimization. And you see here is MPI ifort. That's good. But here we need to modify something. Yeah, we want to change that line to this custom line here. Okay, no, it's not here. Yeah, we want to just copy and paste here. And we do it the same for the pack libs and scalar pack libs. Yeah. We also do the same for FFT libs, and for the MPI libs, this is the parallel computing library. We have to specify the directory. So I want to check where is the MPI library. It should be something like home. So this is the home directory. I just want to write everything completely, and Intel, and IMPI usually here, and this is the number, and we want to put Intel 64 and lib, where you can see libMPI C. This is the C compiler, libMPI ifort, and libMPI. So this is important. Okay, so we copy this directory and paste it here. We need to add -L here because -L means to add the directory as a library. Yeah, and just copy. Yeah. And in the end, you need to add -L MPI, which means that L is library, MPI is the name. So it includes all of the libraries that start with libMPI. So everything else we don't have to change. I guess that is all. So what we actually change is that we add the MPI library here, and we change all of the links for the math libraries with the links that we get from the Intel MKL link advisor. And yeah, and that's all. We just save it and clear the screen, and now we can start compiling. Yeah, make -J2 using 2 cores, and PW is the subprogram. So it starts the compilation process, and just take a rest, and have a cup of coffee, and I will see you later. Okay, so now everything is completed. Let's try. So cd test suite as usual, and write make p tel run tests pw0. We first run the serial test, and it's passed. So I will stop it here. And now let's try the parallel version. Make run tests pw parallel, yeah, and see whether it is passed or not. Yeah, you see, it also works. So congratulations, if you follow this video, and now you successfully compiled a parallel computing version of Quantum Espresso on your computer. So in the next video, I will show you some basic examples of how to use Quantum Espresso and what is the input file, and we will calculate a simple quantum system. Okay, I thank you for watching and hope to see you next time.